Hello, this is Bob. Bob is a PhD student in the software engineering research domain. He found this paper closely related to his own research and that implements a tool he wants to compare with. Fortunately, the tool is linked in the paper, so he looked it up on the web, but he found out the link is broken. Therefore, he decided to contact the original author and ask him whether he could provide him access to that tool. This is the answer he got. Hi Bob, unfortunately this tool is not available anymore, but however it's very easy to implement it yourself. Well, this leaves Bob clueless since now he has to implement this tool on his own without any benefit, and he cannot ensure whether it is done correctly and with the same performance as the original one. I think this kind of story happens to almost all of us, and actually Bob is no fictional character but my colleague Robert Heumüller. So Robert Heumüller, Jacob Krüger and me, Sebastian Nielebock, decided to have a closer look on this issue, and together with my supervisor Frank Ortmeier, we published a paper about this issue. When we talk about software artifacts and software engineering research, we talk about all kinds of implementations that we use to produce our research results. These can be simple prototypes and scripts, software projects up to full-fledged tools that are also used in industry. And we use these tools for multiple purposes, for example to automate software development processes, to support software engineering research, and also to be a leverage for transferring techniques into industry. Moreover, software artifacts are considered very important in the software engineering research domain by implementing several artifact and replication tracks at several venues and to award artifact badges. However, still we observe this discrepancy between importance and availability of software artifacts. Therefore, our research goal was to collect evidence for this observed low availability of software artifacts and to check whether available software artifacts have a positive impact on our research. For that purpose, we analyzed software artifact papers, so papers that use own software artifacts to create their research results, or where the research results are their own software artifacts. And we particularly looked at papers published in the main research track of ICSE from 2007 to 2017. We asked the following three questions. First, what is the prevalence of SAPs at ICSE? Second, if and how software artifacts are published. And third, whether publishing and making an artifact available has a positive impact in terms of citation number. We considered first guidelines on publishing software artifacts, and here we considered general guidelines from several journals and conferences about artifact publishing, as well as the guideline for the ASIM artifact badges, and also from industrial research, the NASA Open Source Software Projects guideline. We collected features that we want to analyze, in particular whether the paper is in SAP or not, what kind of paper type it is, whether the authors named or identified their artifact, whether they linked their artifact with an URI, and whether the artifact was also available through that API. We documented the website and archive type, the distribution type, and also several other meta informations on the paper. We used several resources to collect this information as well as the papers, and we collected a set of 792 papers, from which we have to exclude 3 papers that were not part of the main research track of ICSE. We then split this dataset based on an author-based clustering and mapped these clusters to 3 analysts, basically the first three authors. We then skimmed through the papers, read the papers, checked whether they contain a software artifact and the URI, and checked whether the software artifact was also available through that API. We did that in 3 stages, by first looking at the most earliest and most recent years, collect and compared our results and aligned our analysis. Then we analyzed the remaining papers, and finally we cross-checked a set of papers and found out our error rate to be less than 10%. Regarding the prevalence of SAPs, we found that SAPs are very prevalent with a proportion of 76.6%, and this trend is also consistent among all the years we observed at ICSE, as shown here in the graph. Moreover, we observed that most papers at ICSE are technical papers, and most SAPs also stem from these technical papers. Regarding the publishing of software artifacts, when we considered those 604 SAPs, we found out that more than half do not contain a URI to that software artifact, and even worse, almost half of them also do not have an available software artifact through that URI. However, we can observe that there's a positive trend regarding linked and available and linked and not available SAPs with an increasing number. Interestingly here is that the number of non-available artifacts cannot be explained by solely decayed links, so links that become broken over time. As we can see here, the linear regression, the solid and dashed line are almost parallel, so there's still a consistent group of non-available artifacts even though they are linked. Regarding the impact of publishing software artifacts, we considered the citation number, and to compare citations among different years, we normalized this number by using the average relative citation, which is basically the number of citations for one paper divided by the average citation number of all papers published in the same year. So this creates a rational number, and if this number is above 1, this means that the paper is more cited than the average number of papers in that same year. We analyzed several properties, whether the SAP linked the artifact, whether the artifact was available, and whether the artifact was named. And we could observe that all numbers increase. However, only when the artifact was linked, we could determine a significant difference with a positive effect size. So our results show that software artifacts are very prevalent in the software engineering research community, particularly at ICSE, that still there is a low availability even though there is a positive trend, and that linking software artifact is a slightly positive correlated with the citation number. Regarding the future work, we want to have a deeper look on reasons why we're not publishing software artifacts. We discussed some of them in the paper, and there's also ongoing research on that, but we also need solutions for them. We want to extend our analysis also for other SE conferences, and we also want to compare to different computer science domains to look whether other domains have better solutions for these problems. We also want to find different metrics for measuring impact of software artifacts, not only citations. It's a fairly easy metric, but maybe it's not the impact we want to achieve. For example, we also want to have industrial impact. And finally, we also want to measure the effect of batches that are recently introduced in several venues. And here we also ask, okay, is it better to have static batches, and do they create more sustainable software artifacts, or do we need something like a living batch that updates when our software artifacts achieve a certain maturity, for example, a certain number of reproductions or extensions? This closes my talk. You find our replication package and data on Zenodo, and the paper is open access on Springer IMSE. And now I'm happy to take your questions.